All right, let's work on starting in standard form and writing in vertex form and then trying to sketch a graph. So if I want to write this in vertex form, I do have an equal sign, so it's up to you whether you want to keep everything on one side and do this like you would with an expression or move things over to the other side with G. Either way will work. So I'm going to start favoring keeping it like an expression because I'm seeing enough confusion when we switch up our methods. So I'm just going to say I want to mentally block off the x squared and the x term. I really want a 1 in front of the x squared, so I factor out the 3, which leaves me with an x squared. When I factor negative 3 out of negative 12, I'm left with positive 4. Remember, you can always check by distributing back in and making sure you get what you started with. And then I have a minus 8 out at the end that I'm just ignoring. It's the extra stuff. To complete the square, I'm going to cut that in half and square it, which gives me 2 squared, which is 4. Since I have added, what did I really add? I really added negative 12. Okay, so how do I want to say that? I have an extra minus 12 in here. So to balance that out, I'm going to add a positive 12 to this thing, or subtract negative, however you want to think about this. Okay, so negative 3, and now I can factor that into x plus 2 squared plus 4. So I know complete the square was hard, but we've done it enough that I'm hoping this is starting to feel fairly painless and be a pretty good tool that we can use. Okay, so I want to find my usual y-intercept, vertex, x-intercept, and I'm going to just do a sketch over here. I didn't leave myself room for it. So let's see, the y-intercept of the graph, plug 0 in for x, and I get negative 3 times 4 plus 4, so negative 12 plus 4 is negative 8. Okay, so our y-intercept is 0, negative 8. Let me find the vertex before I decide where I want to put my x-axis. To find the vertex, I shouldn't have to do any work from vertex form. If I have an x plus 2, that actually means the graph moved to the right 2, or to the left 2, sorry, it does the opposite of what it looks like. So it's going to have an x coordinate of negative 2 on the vertex, and that plus 4 out at the end means it moved up 4. So my vertex is at negative 2, 4. I had a negative 3 out in front, so I know it opens down. Okay, so I think I'm ready to start here. I'm going to say I need to get to negative 2, 1, 2, 3, 4. That's going to be my highest point. I need to cross the y-axis way down at negative 8. 6, 7, 8, something like that. X-intercepts. So let's say we want 0 to equal negative 3 times x plus 2 squared plus 4. Okay, so I'm going to subtract 4. And then I'm going to divide by negative 3. So I get 4/3 equals x plus 2 squared. Then I can take the square root of both sides. Don't forget your plus minus. So I get plus or minus the square root of 4, which is 2, over the square root of 3. And that's equal to x plus 2. And then I can subtract 2. So negative 2 plus or minus 2 over the square root of 3 equals x. I don't know if this will help me at all, but we could rationalize our denominator. That might make it a little bit easier to figure out. So negative 2 plus or minus 2 root 3 over 3. Okay, so my x-intercepts are at negative 2 plus 2 root 3 over 3, 0, and negative 2 minus 2 root 3 over 3, 0. Okay, so on my picture, negative 2 is the middle. We already knew that. So we're going left or right, 2 root 3 over 3. Let me just get you a decimal approximation on this one. I won't be lazy. Oops, calculator. There it is. Okay, so 2 root 3 over 3 is approximately, this is about 1.15. So we're going to go 1.15 to the right, and we're going to go 1.15 to the left. My pen's quitting. And that is where we cross the axis. So again, write it down exactly, but on your graph, you can just kind of approximately figure out where that's going to go. Try and make sure these don't have points. They should be rounded. Okay, and there's my sketch. So hopefully this gives you a pretty good idea on graphing. Let me know if you need me to track down more videos. I absolutely will, or if there's anything particular you want to see. I did tack on one more question here just to go back to some work we did earlier. We want to know when the graph intersects y, or L of x equals 3x plus 4. So I already have a picture. I even can kind of get a rough idea. Y equals 3x plus 4, L of x equals 3x plus 4, has a y-intercept of 4 and a slope of positive 3. So it's going to go something like this. So it looks like it hits the graph somewhere around -1, and then it should hit the graph again somewhere way out here. So if we want to figure that out algebraically, what we're really being asked to do is solve a system of equations. So we have y equals -3 times x plus 2 squared plus 4, and we have y equals 3x plus 4. And I'm temporarily going to hide that function notation because while the name L emphasizes that that's the function that multiplies by 3 and adds 4, I'm really just interested in the fact that it has y values and my original function g has y values, and I want to know when the x's and y's are the same. So this is a nice easy substitution. If y is the same as 3x plus 4, then in equation number 1, I can just replace y with 3x plus 4. This is going to not really set up quite so nicely for square root method, so I'm going to go ahead and start multiplying it out. X plus 2 squared is x squared plus 4x plus 4. One nice thing does happen. I could subtract 4 from both sides, and it just goes away. So I get 3x equals -3x squared minus 3 times 4 is 12x minus 12. And then I can subtract 3. I'm sorry, I can subtract 3x, and I get -15x. Okay, so I set it equal to 0. I'd love to factor. I do notice that I have a common factor of -3. So I can divide both sides by -3, and it doesn't actually do anything to the left-hand side, but on the right-hand side, -3 over -3 is 1, -15 divided by -3 is +5, and -12 divided by -3 is +4. So let's see, x plus 1, x plus 4 equals 0, which means x is -1 or x is -4. Okay, so we actually got fairly nice solutions. Each of those should get a y to go with it, and I would just use that linear equation. Looks a little easier to me. If I plug -1 in there, I get -3 plus 4, which is also -1. So let's remove the x equals and just make that a point. If I plug in -4, I get -12 plus 4, which is -8. So when you're solving those systems of equations, what you're really doing, one way to think of it, is you're finding points of intersection between those two curves. So these two graphs, -1, hold on, let me think about that. -3, oh, -1, +1, that's better. This is where graphs are really nice. If I plug in -1, I get -3 plus 4, which is +1, which makes much more sense on my graph. So they cross at -1, 1, and this is way down. It looks like it actually, my graph's a little crooked. It shouldn't be quite as low as I made it. This should be at -4, -8. So solving systems is like finding intersections between two curves. One other thing now that we talked about graphs that I wanted to mention, you could think of that equation right there as telling us the x-intercepts of y equals negative 3x squared minus 15x minus 12. And when you divide out that negative 3 and nothing happens on the left-hand side, it feels like you're just losing information. But what's really happening there is we're saying that that negative 3 that you multiplied everything by, it makes it upside down and it makes it taller and skinnier, but it doesn't change where it crossed the x-axis. So this is going to be rough. But for example, if that negative 3x squared minus 15x minus 12 crosses, we know it crosses at -1 and -4, it's going to be a tall, skinny graph that's crossing at those 2 points, and it's opening down. X squared plus 5x plus 4 is not as tall and skinny, and it opens up, but it still crosses through those 2 points. So when you're solving a quadratic and you just divide a number out and it disappears, that's really all you're doing is saying, I don't care how tall or skinny it is or what way it opens, as long as I know where it crosses the axis. Okay, thanks for watching.